This is the third standard for grade 3. Explain equivalence of fractions in special cases and compare fractions by reasoning about their size. One thing to understand about equivalent fractions is that they represent the same point on the number line. So let's look at a few basic cases, right? These are all equivalent fractions. I'm gonna write it down on the next page, but for now let's make note of it. 2, 4 over 2, 2 over 1. Should not forget these. These are all equivalent fractions. Why? They're the same point on the number line. And once again, 3 over 1 and 3, 6 over 2 and 3. These are all equivalent fractions. Okay, so I'm going to write that down on the next page. And it's very simple for us to understand. What are equivalent fractions? They're simply this. They represent the same point on the number line. Let's write that down. So far we have learned, or we have seen that 1 equals 1 over 1 equals 2 over 2, and that equals 3 over 3. And we've also seen that 2 equals 2 over 1, and also 4 over 2, and also 6 over 3. And then we saw for 3 over 1, that also represents 6 over 2, and that also represents 9 over 3. So this is our kind of introduction to equivalent fractions. And another important concept is here, that's stated here, is that whole numbers are indeed fractions. 1, 2, and 3 is indeed 1 over 1, 2 over 1, 3 over 1. You know, this is just as much 3 as 3 over 1 is, you know, if that makes sense. But 6 over 2 is also 3. 9 over 3 is also 3. So there are different ways of representing the quantity 3. This is 3. This represents 3. This represents 3. And this represents 3. Now, let's look at the case of why 1/2 is equivalent to 2 over 4 using a number line. Right? We both have a whole in this case. Let's just go from 0. Here's 1. Here's 1. Here's 2. Here's 2. Here's 0. So now again we're letting the length of 1 on the number line represent the whole. Here we're partitioning it into 2 equal parts. So that represents 1/2. Here let's partition the whole into 4 equal parts. So this would represent 1 over 4, 2 over 4, 3 over 4, and 4 over 4. As we can see, 1/2 is equivalent to 2 over 4, simply because it's the same point on the number line. So this makes it very clear that equivalent fractions are the exact same point on the number line, right? And of course, 4 over 4 would also equal 2 over 2, as we can see. Let's write that here. Okay, now let's use a simple visual fractional. Let's use a visual model to represent other equivalencies. So now let's show why let's make 2 squares. Right, let's call these the unit square. They each have an area of 1. Right, we're letting the whole represent the area of the unit square. So in this case, the whole is partitioned into 2 equal parts, and it's one of those parts that are considered. This represents 1/2. Put that there. And now let's partition the whole into 4 equal parts. And it's the parts, 2 of those parts that are considered. Right? This is 2 over 4. And as we can see, they're equal. You know, they're just equal looking, just looking at it. Another way to represent this kind of looking at it from a different angle, is let's just consider 1 square. This is 1/2. The red represents 1/2. Now let's partition the square into fourths. And we can see that now that the whole is partitioned into 4 equal parts, 2 of those parts considered are this and this. So we can say that 1/2 equals 2/4. Okay. Now in this square, let's show that 1/3 equals 2/6. What does 1/3 represent? 1/3 is simply the whole is partitioned into 3 equal parts, and one of those parts are taken or considered. That represents 1/3. Now let's partition the whole into 6 equal parts by creating one horizontal line. Let's make it better. Now the whole is partitioned into 6 equal parts. Therefore, 2/6 would be 1, 2. Right? As we can see, 1/3 equals 2/6. Again, 1/3 would represent this is 1 out of the 3, looking at it from that angle. But 2/6 is also 1/3 because 2/6 represents this. So interesting. 1/3 equals 2/6.